So remember, a log has those pieces, right? It's got its base, its answer, and its exponent, right? Now this seems to be missing two because I only see one number, right? Which one is very apparent?
Base is 10.
Well, that's the answer is right there, but you're correct. The base is 10. How do we know?
Because if it's just by itself, because it's so common, it's
Yep, it's a very common log, so we don't need to write it. So really what that says is that. So what else is missing? The exponent, so we will assign that a x. Okay? Now I will say that log of 30 and log of 500, you wouldn't go through all this trouble for. You can just put that right into your calculator, right? You can do log 30, enter, and get an answer. But we're practicing a skill, so we're going to prove it, that we would get the same answer, okay? So this is your new log, right? Now I got all pieces, so I can rewrite it as an exponent. What's my base? 10. What's my exponent? And my answer? 30. Okay, so now I kind of see the situation. It's saying 10 to the something is 30, all right? We know some 10 to the somethings. I don't know any of them that get me 30, but let's think about the ones that we do know to maybe get an estimate down here before we get started so we can make a prediction. 10 to the 1, that's 10. 10 to the 2 is 100. So I've already passed the number. So it's got to be between 1 and 2. So what do you think? 1 point what? 1.4-ish? Okay, so that's our guess. Okay? But we learned last class how to not guess, how to get an actual exact answer, right? And this was the process we needed for our homework and for going forward, okay? So I set up that equation, 10 to the x equals 30, right? And I now learned that I can do what to both sides of this equation? I can log both sides of this equation. So I log this side, and I log this side, right? Why did I do that? Well, not yet. There's a property that's going to happen here. What property? Remember, the problem was the x is in the exponent. Yeah, so I get it out of the exponent, right, out front, and I end up with x times log of 10 equals log of 30, divide by log of 10 on both sides, and I'll have just x, because these will cancel, and I end up with x equals log of 30 divided by log of 10 in my calculator, which is 1.477. Okay? Now, I could check my work. How? A couple ways. In this case. Yeah, plug it in. 10 to the 1.477 should get me pretty darn close to 30. Now, that was a rounded number, so it's not going to give me exactly 30, but it should give me really, really close, and then I know I did it right. And in this case, there's an extra check. You could actually just do log of 30 in your calculator, because it can do that, because it's base 10, and you should get the same answer. Okay, so now that you have an example on the board, if you weren't able to attack these problems, try the next two. I'll give you a few minutes, and then we'll get going. All right, so log 500. Well, we just had an example that we had a missing base. We know that that base is actually 10. So really what this is saying is log base 10, 500. And what do we not know? The exponent. So we put an x there, right? So that allows us to rewrite this as 10 to the x equals 500. Now, if we want to estimate, we go through that process again. We already know 10 to the 1 is 10. 10 to the 2 is 100. 10 to the third is 1,000. Okay, so we passed it. So what number must Rx be between? 2 and 3. So we'll say 2 point what? Is that a guess or an answer?
That's what I
Okay, 2.7.
I guess 2.5.
Between 10 and 100.
So because 10 squared is 100, and 10 to the third is 1,000, it's got to be between 2 and 3, right?
I changed it to a 50, my bad.
That's okay. So it should be between 2 and 3, 2.7. If you said something along those lines, whatever. There's no right answer to a guess, as long as you're in that zone. All right, so now we find the actual answer. So I have 10 to the x equals 500. And because we don't know that, we have to find the x. We get it out of the exponent by logging both sides. Yep. Log. And this x comes out over here, and I end up with x times log of 10 equals log of 500. Divide by log of 10, log of 10. And I get x equals 2.699. Well, if we rounded, that would be 2.7. What a guess. Good job. Okay. So, last one. Okay, so these, again, you could just put log of 500 in your calculator because it's base 10, right? But assuming you don't have a graphing calculator, which you wouldn't for a quiz or test, right? You would then need a new tactic for this one because you can't just do log base 230 in a scientific calculator, right? You need a way to do this algebraically, which is what we learned last class. Again, our missing pieces are exponent. So our base is to the x equals 30. So we're asking log 230 is asking you 2 to the what equals 30. That's what a log is asking you, right? The log is the exponent. So I go, okay, I know like 2 to the 4 is 16. What's 2 to the 5? 32. Okay, so I passed it. So we know our answer has to be around what?
4.9.
Okay, I'm hearing between 4.4 and 4.9. I'm going to say 4.7.
Wait, but
I guess 4.8.
I mean, I heard 4.4, so I'm going with the average of the class. Okay, I would agree that it should be closer to 5 than 4. But we'll go with the class. It's class average, ready? 2 to the x equals 30, right? And then I log. Should be a song that goes with that, log. And I get x times log of 2 equals log of 30. Divide by log of 2. And I get x equals 4.9. We'll say 1. Wow, we were way off. But not really. 0.2, that's not that far off, right? We had the general idea, high 4, right? Now, to check your work, you could go 2 to the 4.91, and you should get really, really close to 30. But not exact because we rounded, right? Okay, so that is the basic skill that we learned last class, okay? Now, it can get more complicated than that, so let's go to the homework. Today's lesson, okay, so today's lesson is 2 topics that have very little to do with each other, except that they both involve logs. But neither of them deserve a whole class period, so they're both in this lesson. Okay, so we're going to do like here's one thing, here's another thing. Okay, so that's good news because both of them are pretty short, right? They don't require a ton. They're pretty simple. I think you'll be able to do both of them pretty easily. Hopefully, we'll see, right? All right, so let's talk about graphing logs first. Now, your goal will be to graph this. Now, I'm not going to give you this whole setup you see here every time. I'm just going to say graph that, okay? But I'm for now, to start you out, I'm going to show you why this matters too. Okay? So, what do we know? What do we remember about this and this? Like, what do they have to do with each other? They're not quite the same. So, if you notice, what's the exponent there? It's y. Right? And what's my exponent here? What's my answer there? What's my... So, do we remember when we would flip y and x, what that was called? Talked about inverses, right? These are inverses of each other. Right? They are opposite functions. You are right that it looks like rearranged, but if you pay close attention, actually, the x and the y change position, right? If you turned this into a log, it would actually be x equals log base 2 of y. Your inverse of that, you flip the x and the y, and that's how you get that. Now, why does it matter? Why would we care about this? Because we can do the flip. You can flip your x and y. And we want to graph that, right? We know how to graph this already, right? So what we're going to do to graph that is graph this and just flip it. Okay? That'll be our strategy. Okay? So let's start with some pieces here. A little review of graphing exponential equations. This will be helpful for your quiz. So remember, it's y equals ab to the x. That's an exponential equation, right? What is the a here? It's 1, right? This is really saying like y equals 1 times 2 to the x. So our a is 1. What is our b? Our b is 2, our multiplier, right? Now, what was our strategy for this when we wanted to graph these? Anybody remember? Make a table. Now, usually when we made a table in this class, we just picked some random x's, and then we plugged them in, and we found our y. But what point did we know to start with here? What point was given to us, just easy? The intercept, right? 1. Because at 0, we know the y value must be your a, which is 1, right? And yeah, we do want to know more points than that, but we don't actually have to do much plugging in here, because we also know our b, which is our multiplier. So to get to the next point, I would just multiply by 2. Is this sounding familiar? Right? Over and over again. 1 times 2 is? 2 times 2 is? 4 times 2 is? 8. What if I wanted to go backwards 1 to get a negative? What is 1 divided by 2? 1/2, right? Or 0.5. Okay, now I'm going to graph those points, right? So negative 1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8, and that takes us off the graph. Remember, we hug the x-axis, and then we go straight up, and there's our graph. Yep, 2 to the third is 8. Yeah, you could also do this the old-fashioned way. You could plug every one of these in and still get the y's if you forget this trick to go faster, right? You could plug every one of those into that function, and you will get your y. Okay? Now, why did we do this? Well, actually, before we do that, some key points that always show up when you have a of 1. You will always get 0, 1, and you will always get 1 and your base. Very good. In this case, we had 1, 2. Okay? 1 in your base. That will always show up. Now, if we flip all this, right? I literally just take every x, y, and I flip it. If negative 1, 1/2 is a point on that graph, what is the point on this graph?
Negative half. 1 negative half.
Just switch their places.
Oh, half of
1/2, negative 1. If 0, 1 is a point over there, 1, 0 is a point over here. If 1, 2 is a point over there, 2, 1. What's my next point? 4, 2, 8, 3. Right? Yeah. but that would be off our graph, so I didn't put that one in. Okay, and now I just graph those, right? So 1/2, I would just go halfway to 1, and then the y is -1, so that's about there. 1, 0, 2, 1, 4, 2, 8, 3. And see how this hugs the x-axis? Hug meaning gets really close, right? This is going to hug the y-axis. Okay? Now, you'll notice that this thing kind of flips over like an imaginary line, right? That line has a name. It's called the y equals x line. And it cuts the graph right down the diagonal. So you should see that flip if you want to sense check your work. Okay? Now, if the key points here are always going to be 0, 1, and 1b, what are the key points here always going to be? Yep, 1, 0, and b, 1. Those will always show up for you. Okay? So you can use those to sense check your work. And that's it. We have now graphed that log. Okay? The only thing you need to do when you're doing this is I'm not going to set this all up for you. I'm just going to say graph this. Okay? And you're going to have to think to yourself, well, what's the exponential inverse of log base 2x? Well, it's always going to have the same base. It's always going to be y equals. What's the base? 2. And then you just add a to the x, and you have the inverse. Okay? Right? So then you graph that, flip it to get that. Can you try it? Okay. Try it with, well, hold on. Let me write the steps. They're very simple. Step 1, you find, write, and graph the exponential inverse. So what does that look like? Well, if you are asked to graph like y equals log any base x, the inverse of that is y equals that base to the x, right? So if you graph that, you'll be able to graph that with the second step, which is flip all x, y, bless you, points to graph your log, and you're done. And as I was saying, that's what I'm going to have you do now, is do this same process, and I'll leave it up on the board for you so you can see it in case you didn't finish your notes, with 10 to the x, right? Now, what I would normally do going forward is just say, graph that. And you would have to know, I need to find that, graph that first, flip all the x's and y's, okay? But right now I'm setting it all up for you. On your homework, that won't be the case. All right, I'll leave this on the screen while you work on that. Okay? Okay? All right, so I graphed this first one using the same exponential process that we've used. Now I flipped all of them. So 1/10, that's almost 0, right? And then -1, that's down here. And then I have 1, 0. And then I go all the way out to 10, 1. And then it's to 100, so I'm off the graph. I hug that y-axis, come through these points, and there's my log graph. Okay? Not bad, right? Just got to flip all those x's and y's. If you already know how to do this, it's the only extra skill. Okay? All right. Now, next topic. What if a logarithm equals another logarithm with the same base? So, I got log base 5x equals log base 510. If you had to guess, what do you think x would be here? Why do you think that's true?
It equals. It's like all the parts are the same.
Right, because they're the same, and this thing in the middle tells us what? That both sides have to be the same value, right? And what other way could that be true? Okay? Now, we can prove it if we want to, right? You don't have to do this ever again, but I can show you how to prove it. If you have log 5x equals log 510, and I got them both to one side, I would subtract log 510 from both sides, which gives me log 5x minus log 510 equals 0. Subtraction on the outside means what on the inside? Division. So this becomes log base 5 of x divided by 10 equals 0. I have a base, I have an exponent, I have an answer. So I would just rewrite this. 5 to the 0 equals x divided by 10. What is 5 to the 0? 1. 1 equals x divided by 10. How do I get x by itself? Multiply both sides by 10, and I get x equals 10. Okay, proven, right? Proven to be true. Do we have to do that every time? Absolutely not, because this is a property, a rule, a law, right? So we can just move forward with this knowledge. If logs are equal and have the same what? Yep, very important. Then their answers are equal to. Right? You can make a very complicated thing become very simple. Right? If I have this one, well, are the bases the same? Log 5, 4x, log 5, x plus 12? Bases the same?
Yes.
Yes. The answer here is 4x. The answer here is x plus 12. What do we know is true about them? So what can I do? Yeah, therefore, 4x equals x plus 12. It's very similar to the common basis of, this is called the common base log property. We already talked about the common base exponent property. Same concept, right? The only thing that can make this true is if they're the same. So we set them equal to each other, minus x on both sides. I get 3x equals 12, and then I divide by 3, and x equals 4. If you wanted to, you could check your work, right? What is 4 times 4? What is 4 plus 12? Log base 5 of 16, whatever that is, probably would equal log base 5 of 16, whatever that is, because it's the exact same thing, right? Even though we don't know what it is, we know it's equal, okay? And that's it. That is, like I said, pretty straightforward. That should be a nice gimme on a quiz or a test, okay? Just remember, you can set them equal to each other, okay? We'll talk about maybe some examples of being more complicated. But first, on the front side of the homework, we dealt with some log properties. So that was, now so far, well, not so far, in total we have our product, which is adding on the outside, multiplication on the inside. We have our quotient, which is division on the inside, subtracting on the outside. And we have our power, which is exponent on the inside, goes to the front. So we have all three. We can use all three to expand or condense. So first section was asking you to expand. Does anybody want to see any of these?
4.
Number 4? Okay, so number 4. Okay, so if you have a radical and you have an exponent, right, the first thing you want to do, just like when we had exponent properties, is make them both exponents. Like you don't want to be dealing with both, right? So the first thing I'm going to do is rewrite this as log base 6 11 to the 6, and then instead of the square root of 2, it's 2 to the what? What's the exponent version of square root? 1/2. So I have 2 to the 1/2, right? Okay, now I take a look and I say, oh wait, I got multiplication on the inside. That means what on the outside? Adding on the outside. So I'm going to break this into 2 logs, log 6 11 to the 6, plus log base 6 2 to the 1/2. Okay, so I've done the product one, right? Now I also see these exponents on the inside. We know that they can go where?
On the outside.
To the front on the outside, right? So both of these are going to move to the front. So I get 6 times log base 6, 11, plus 1/2 times log base 6, 2. And then 1/2 log base 6, 2. You can throw that 2 right underneath, and that's how you get to this answer here.
Number 2.
What's that?
I have number 2.
Number 2 as
I'm
well?
not sure about
Okay, so number 2. All right, so you could do this a couple ways. I would say easiest way is I see this 4 inside on the inside. What can I do to that 4 right away?
Put it on the log, like before the log.
Put it out front. So now I have 4 times log of 3 over 2 to the 4th. Okay? And you don't have to do this way. Some people applied the exponent right away, probably. But this kind of avoids power to a power. Okay, so now I have division on the inside, right? What does that turn into on the outside? Minus. Now here's the key. It's 4 times this log, right? The whole log, right? So if I pull it into 2 pieces, I need parentheses. Log of 3, it was just base 10, right? Log of 3 minus log of 2 to the 4th, right? Now, before I distribute, I notice something else I can do over here. What can I do over here? Put that exponent out front. So I have 4 times log of 3 minus 4 log of 2. Now I'm going to distribute that 4 through. I get 4 log of 3 minus 16 log 2. And that was your answer. Okay?
Oh, I simplified it even further.
Well, if you could factor out a 4 there, but that the answer key did not, because it said expand. Okay, let's move on to condense. Anybody have any questions on any of these?
Can you do number 13?
In 5 through 8 so far.
8.
Number 8. Okay, so number 8. How do we add? These are all fractions, right? What allows you to add or subtract fractions? Do they all have the same denominator?
Yes.
So can I add them together?
Yes.
Okay. So that means I can say that this is all over 2, and I have log 7a plus log, didn't even wait for it that time. It's like multiple times a day at this point. All right. As I was saying, okay, so common denominator, 2. So that's log 7a plus log 7b plus log 7c. Okay, now I have some adding going on the outside, right? So that would be multiplying on the inside. What multiplies? The answers, right? Well, my 3 answers are A, B, and C, right? So I end up with log, go ahead, 7.
7 to multiply A, B, C.
Yep, A, B, C all on the inside, right? Over 2. Now, we talked about in class yesterday, dividing by 2 is the same as? Right, multiplying by 1/2 on the front, which would then become an exponent. So I'll show that in steps. That's 1/2 times log 7 ABC. And then that, of course, would go into the exponent spot, which will become the square root. So log 7 ABC to the 1/2, which, becomes log 7 square root of ABC, or as they said, CBA.
Which makes no sense.
Yes.
Put it into ABC.
Yeah, it's backwards because you're supposed to put it in alphabetical order as far as I've been told my whole life. But I don't know. Can't control their answer keys. They're wild. Okay, so that was condensing. Okay, that was a good example. Now on the back, 9 and 10 were very much like our warm-up. So let's focus on the rest of these. Which ones do we want to see? 13. Okay, so 13, if you have this, remember we said we have to isolate the part with a variable in the exponent. What part is that?
That is minus.
It's this whole thing, right?
It's 5.
So I need to do what to get that by itself?
Divide by 6.
Divide by 6, divide by 6. So I end up with 5 to the m minus 5 equals, and what is 89 divided by 6? 89.6. Now, you're not wrong, but in order to put a decimal, what do you have to do? Round. And that if you round in the middle of a problem, it will give you a different answer at the end. Right? We talked about that yesterday, I think. So now I want to get that variable out, so first I have to.
Multiply it by log.
It's not multiplying, but I hear you. Log both sides.
Log versus.
Okay, so if I log both sides, now what is the exponent here? It's the whole of m minus 5, right? It's this, right? So that whole thing goes out front, and I end up with m minus 5 times log of 5 equals log of 89.6, right? Now, I want to get m minus 5 by itself, so I divide by log of 5 on both sides. And this will be a little bit to put in your calculator, but log of, parentheses, 89 divided by 6, parentheses, divided by log of 5 gives you m minus 5 equals, now I'm ready for a decimal. In a moment. 1.675. Okay? Taking your word for that, because I don't know that off the top of my head.
Doesn't it show the answer on your...
Yes, but I still have... Yeah, you're right. Okay, so now I would add 5, equals 6.675, and I had 6.6757, so I just want one more. Just be careful what it asks for in terms of the number of rounding pieces. Yeah?
I forgot to round to be 0.676.
Okay, but actually we would, since it said go out 4 decimals, I'm actually going to just add to that. So, because I think it specified 4 decimals in the instructions.
Yeah, the 10.
Yeah. All right. Other questions? 15. All right, so 15. Is this a log problem? No. It can be a log problem if you want to put a lot of extra work into it. But what do we notice on each side here? I got common bases, 4 and 4. When you have common bases, what's true about the exponents? They're equal. Yeah. Negative m minus 1 equals 3m. Solve for m.
So I did all that work for you.
No, you got really good practice with your logs.
Plus 1,
Well, I
plus
got
1.
a completely different answer. I didn't
Yeah,
get negative
therefore.
4. I got m equals negative 0.5.
M 3.
You were close.
M equals 3. Oh, wait.
We can solve that, right? Do you want me to do it? Add m to both sides. 4m equals negative 1. Divide by 4, negative 1/4.
Yeah.
Right? Okay, any other ones we want to see? I think we've kind of hit the pieces. Just if you have something like this, I'll just add this, right? This is what you're isolating, so get rid of this. Right? So minus 8. Once you do that, then divide by negative 6, divide by negative 6. Always add and subtract first, then multiply or divide, then log both sides, and you're done. Okay? All right, ready for the lesson. All right, so today's lesson